All right, good afternoon, everyone. Looks like everyone made it through the day for the last session. So I think all that stands between me, or you rather, and tonight's party is this talk. So hopefully we'll make it entertaining. I'm going to be talking about planning for failure in cloud applications today. And actually, a real quick question. How many people here have built cloud applications in Windows Azure, just out of curiosity? So actually, very few, about 6 or 7. How about in AWS, Amazon's platform? About the same, OK. So I'm actually going to be talking today fairly in the abstract, although I'll try to solidify things with specific examples on both the AWS platform as well as Windows Azure. And of course, my background is largely Windows Azure based, so I'll probably go into more depth when it comes to Windows Azure, and hopefully that's OK with everyone. I think it's OK with Ryan and some of the Windows Azure track owners. So that's good. But yeah, I want to talk about some of the patterns and some of the things that you should think about when it comes to planning for failure. Because if there's one thing that you can count on, it's that something is going to fail at some point. And there's some systemic things that you can put in place to help mitigate some of these failures, as well as some things you should be aware of in the different cloud platforms in order to help you recover from and mitigate some of these problems. Not sure if any of you have been at some of the earlier talks that I've given today and yesterday, but in case not, just some real quick background. My name is Wade Wegner. I work at Aditi Technologies. I've been there for about 4 months. I'm the CTO there and focus on a lot of different things. But prior to Aditi, I was the Director of Technical Evangelism for Windows Azure and worked on Windows Azure for about 3.5, 4 years, actually prior to when it was released in 2008. You can follow my blog. I actually put most of the information I either talk on or a lot of things I don't talk about up on the blog, so hopefully some good resources. You can find me on Twitter and would be happy to engage in some dialogue with you. And then I pretty much open source all the apps that I end up building up on GitHub. So if you were at the earlier talk I gave today on mobility and cloud, I actually put both the start and end state solutions up there already, and you can find a whole bunch of other stuff there as well. So feel free to take a look. So we're going to talk again about planning for failure. And one of the points that I want to emphasize throughout the talk is that it's important to design your apps with failure in mind. And we're going to also review some of the more recent cloud failure. There's been some problems, some outages in cloud platforms over the last couple of years. Talk a little bit about that. And if nothing else, to emphasize the fact that things can and will fail at some point in time. And we're going to talk a little bit about some of the building blocks that you can put in place, both at an infrastructure level, as well as some of the automation that you can put in place to help you recover from and mitigate some of these challenges. And then at later on in the talk, we're going to walk through some different patterns in terms of some high availability options, as well as some disaster recovery options that can help you recover from some of these things. And then we'll hopefully draw some conclusions at the end. What I want to take away, you to take away from here are some things that you can put into place immediately. So some of the material we'll go through is actually, like I mentioned before, there's going to be some processes that hopefully you're already using, but there's probably 1 or 2 things that you may look at and say, yeah, that's maybe not a bad idea, something to look at. So we're going to go through a lot of those different options and talk about them. So we'll go through them in detail. As well as some best practices for implementing them on the platforms in particular. So, how you might implement something on Windows Azure versus AWS. And then we're going to cover some of the specifics about the platform. So for instance, AWS has a concept of multi-availability zones. And then Windows Azure has something that's very similar called fault domains. And so we'll talk through some of those differences, as well as multi-regions and some multi-cloud opportunities as well. So these are the things that I'm hoping you will leave the talk with, and some ideas and things that you can bring back to your companies and to the projects that you work on. So why plan for failure? I mentioned that one of the things you can count on is that there will be failure at some point, whether it's the cloud platform, whether it's a bug in your application, whether it's some sort of human error, someone dropped the table in a production system, things like this. They happen all the time. Now, from a platform perspective, both for AWS and for Windows Azure, there have been some pretty highly visible outages in the last couple of years. In 2011, Amazon actually had an outage that was caused by power failure. It actually generated some faults in the EBS, which is the way in which they do storage on the platform, and it ended up cascading into an entire region going down for Amazon. Windows Azure had a bug earlier this year on February 29th. Does anyone know what February 29th is and What's unique about that day? It's leap day. And turns out that there was actually a bug in software where someone tried to create a certificate based on the date, and the way in which they were creating it in code actually threw an exception and caused the entire Windows Azure platform to go down. So these things happen, and some cases you can try to do things to help mitigate the failure and what happens. In some cases, you just need to be prepared for it and figure out what the best opportunities for recovering your applications are. And even more recently, this summer, there were some AWS errors. And then on July 26th, which was actually, I think, about a week before TechEd Europe, there was an outage in one of the data centers within the European zone for Windows Azure. So these things do happen. And I just want to emphasize that you need to think about it because, like I said, it will happen. So through the talk, there's a couple of different things to take into consideration. We want to talk about fault tolerance, and this is really how tolerant your system is to things happening that fail. Like, what happens when the network goes out? What happens when you don't have access to storage? Like, if your application, you've got multi-tier application, you've got a database backend, you've got a web front end. What happens? How does your web application respond to the database not being available? Is there an exception, or does it provide some other way of mitigating or recovering from or presenting some other opportunity or option for a user? There's also considerations around high availability. And these fault-tolerant systems are measured by how highly available they are. And usually, it'll be paired with something like an SLA or a guarantee or some kind of an agreement for the amount of uptime there is. And so I listed out some of these because unless you've really taken a look at it and thought about it, you may not realize what significance certain levels of nines actually end up having. So 99% availability is actually 3.65 days of downtime a year, potentially. Whereas 99.999% is about 5.25 minutes of downtime. So these are things that are attached to highly available systems, and you need to be aware of ahead of time as part of figuring out what your options are. And one thing that I wanted to cover is what happens when you've got multiple systems you're using that have different SLAs and guarantees. So here's an example where with Windows Azure, if you're using compute, as long as you have 2 instances running, because then you'll take advantage of multiple fault domains, you'll end up getting an SLA of 99.95%. Now let's say your application is also using SQL Azure, which has a SLA of 99.9%. And then maybe you're also using Windows Azure Storage for hosting images or some other resource. Well, what does that actually mean in terms of what your SLA is for the application? Like, you have end users that are using your app. What kind of guarantees can you offer to them when you're using cloud platform? Well, one way to look at it is, well, let's look at the potential downtime based on these SLAs. So based on these values here, just plug it in. So for Windows Azure Compute, that's potentially 4.38 hours. For SQL Azure, 8.76, and then also for Windows Azure Storage, 8.76. That comes out to potentially 21.9 hours per year, because the SLA is not guaranteeing that these things are only going to be out at the same time. They could potentially be cascaded. So your target here is really down to 99.75%. I actually should have put what the total is there. It's probably, well, it's quite a bit lower than a lot of these. So you're looking somewhere between 1.83 days and 3.65 days. So understanding what your options in the SLAs are when it comes to high availability is actually an important consideration, something to think about ahead of time. All that said, I want to actually present one thought about what is the cloud. Certainly, cloud computing means many different things to many people, but as we start talking about disaster recovery options and availability, I want to present an alternate or maybe a nuanced definition of the cloud. And I actually want to think of the cloud as a physical endpoint, like a physical API endpoint that I can interact with. With that in mind, saying that Windows Azure is a cloud or a cloud platform isn't necessarily the case, because Windows Azure defines fault tolerance by a data center. So when I start interacting with my app, that API endpoint is at a data center level. Same with Amazon. When you start thinking about, well, is Amazon Web Services a cloud, or is the the East Region data center a cloud? Because again, it's a physical API endpoint. Is that the cloud? And so I just want to, as we're thinking about this, it's important to frame up what we mean when we say cloud, because if we're talking about it in terms of availability, it matters more about what the availability zones are or what the fault domains are within the application versus this big nebulous system of data centers worldwide, because at the end of the day, if your application's running in one data center and that data center is going down, unless you've got plans to mitigate that impact, it's going to impact you. So I don't know if this makes sense to people. I've presented this once before, and I did an awful job trying to define or explain what I meant by this. But this is one way that I look at it, just because when I talk about availability, I want to be sure that I'm crystal clear about what is it that's available. And to me, it's that data center where the hardware is, where the resources are, where the networking is, and where my app is ultimately living. So if I end up saying the cloud, moving forward, I end up meaning really, a specific data point or set of resources in a data center. So when you talk about high availability, if you wanted to have a highly available application, what this means is that you've theoretically designed a system that has no single point of failure. You probably have a farm of web servers. You've got some kind of redundancy through your network load balancers. It could be software, hardware based. But like if a load balancer fails, there's still a way to route traffic to your systems. You've got a back-end data store that's probably either clustered, or it's mirroring data, or it's shipping data, or somehow getting data to different places so that if that goes down, there's some kind of recovery option. And at the end of the day as well, if and when something happens, you've got a way to recover from that. So these are things that when it comes to designing and architecting the system are things that we're considering and things that we're looking at. So that's high availability. Now, disaster recovery is not saying that we're going to be available through a disaster, but it's when this happens, how are we recovering? And there's actually a lot of different ways to go about doing it. And I'll get into things like there's cold disaster recovery, there's warm, there's hot, et cetera. And there's different ways to design this in the cloud. But disaster recovery is about how you prepare for, what's the process, what are the things that you have in place, what happens, what are the steps, who are the people that respond, the things that you need to do to prepare for it, and then once you've prepared, how you actually end up executing it. And this is what we'll also get to this. Automation and having these things in place is really important because these failures occur from hardware, from people, from networking, from bugs, et cetera. And the more that you can automate these things to prepare for it, the better. The second point there is actually really important. I think something that a lot of companies, and even companies that I've worked for, don't really take into consideration and think about is, it's one thing to plan for, but it's another to rehearse. How many people here have actually set up, like, let's say, just database backups, so you're constantly backing up, but that one time you go to restore, something just doesn't end up working. And it's because you do a great job of planning for and continually backing up, but you don't actually end up doing a restore once in a while to make sure that there's problems, or that there's no problems with your restore. So actually rehearsing disaster recovery scenarios is really important in making sure that you can recover for it. I know on the Windows Azure team, when I was at Microsoft, the ops teams actually do this all the time, and they're continually rehearsing the steps and finding flaws and recovering from those types of things, even when there isn't a disaster, so that when there is, it's not something they're doing for the first time. And then the last thing is, as part of this rehearsal and going through this, is continually revising and taking a look at what you're doing and trying to improve upon it. And this is where, when you get to automation, this is so important, because you can continually improve and revise these ways of recovering. Now, one of the typical approaches to disaster recovery is really duplication. Years ago, I worked for an insurance company, and we had a data center in Colorado, and we had another data center in Virginia. And our method of disaster recovery was to have everything continually shipped. We did log-based database shipping. So we shipped logs. We ended up rebuilding things. And our SLAs were a certain number of hours. I think it was like 6 hours that we'd be able to fail over to the other data center. And what that meant is that it was a very traditional approach to it, where all the hardware that we had in Colorado was mirrored. It was the same in Virginia. We had the same servers, the same disk sizes, et cetera, because we wanted to mitigate any of the challenges we might have when it came to recovering. And so that meant we had to purchase all this stuff, where most of the time it was sitting unutilized and it wasn't being leveraged in the Virginia data center. And so that's the typical approach. And I would make the case that when it comes to cloud computing, that we have a lot of new options and different ways that we can think about it, because we have the ability to procure instantly, or very quickly at least, hardware that we wouldn't have had before. So some differences and things to start thinking about when it comes to disaster recovery in the cloud is taking advantage of some of the capabilities of the platform to make it easier. So for instance, with Windows Azure, if you start looking at Windows Azure storage, I don't know if any of you were in the talk I gave yesterday where I covered some storage, but there's availability and disaster recovery things built into the platform. So the more you can take advantage of capabilities of the platform, the better off you are. So Windows Azure Storage keeps 3 replicas of all the data that you end up storing up there. So if you store blobs or if you store information in tables and so forth, there's 3 replicas so that even in the event of failure at a switch or failure in a disk, there's replicas elsewhere and it can rebuild that data for you. Additionally, it has availability built outside of the data center. So by default, all of your data stored within storage gets replicated to the other data center in that region. So that data gets replicated at least 500 miles away so that if there's some kind of physical, large-scale regional problem, that data is still available somewhere. And so that's Windows Azure with regions. There's also fault domains built into the platform where if you've got multiple applications running in a cloud service, you have at least 2 instances running, they're going to live in different fault domains. And this is why Windows Azure can offer 99.95% availability on top of your compute resources, because different fault domains means that when you deploy your application, it's not deploying that app into 2 machines on the same rack. It's actually isolating everything that it can so that if there's a failure of a NIC, if there's a failure of hardware, if a whole stack of machines goes out, it's in an isolated place within the data center, and your other machine, your other instance, can still be up and running and receive traffic. And then the platform can recover your application and deploy it somewhere else. So understanding those things about the platform helps, and taking advantage of those things can help mitigate some of the disasters that you would end up encountering in the future. Now, Amazon Web Services has a very similar concept. So they do have regions, and regions are areas where there's isolation across hardware. So if you deploy across multiple regions, your chances and the likelihood of suffering some sort of catastrophic failure are much more remote. And they also have availability zones within the data centers, which maps very, very closely to fault domains. Some other things to consider is with the platform, with Windows Azure, you've got other building block services that you can tap into. I keep hearing a beep. Is this from outside? Okay. So not only is there storage, but you've got things such as SQL Azure, which provides a relational database store for you. And that data also has fault tolerance built into it so that if there's a hardware failure, you can still continue to get access to your data. So taking advantage of these platform capabilities is really key. So at the end of the day, the platform can do whatever it can to help maximize the availability of your application, but we're still on the hook for our customers. And so figuring out the right approach, regardless of what the platform is able to do, is still our responsibility in designing and building these systems. And so we're going to talk through some of the different ways in which we can go about doing this. Now, one thing I do want to point out is this last point where, I said traditional disaster recovery today means procuring hardware and basically having this duplicate, over-provisioned set of resources. With the cloud, you have the ability to have a lot of new options where you can spin up these things and through automation deploy these systems much, much quicker, which means that you haven't had to have these things provisioned already. Now, a couple of different things to note, because one of the things that I'm going to recommend is there are some approaches that you can take where you use multiple clouds. And as a former Microsoft Windows Azure evangelist, it may seem crazy for me to say, well, there are times where you might want to leverage some of Amazon as well. And the reason I say this is, we're all going to be responsible for delivering to our customers, whether it's the company we work for or if we're an SI and we're consulting. And we have to find the right balance. If you look at those outages from the earlier slide, even with some best practices, you could have suffered a complete outage of your services. And that, like with Windows Azure, when that leap year bug occurred, it brought down the entire Service Management API, which is uniform and goes across all the different Windows Azure data centers. And so not having an option where you could recover somewhere else, even if it means only 10% of the services you offer, means that, let's say you're Netflix or let's say you're an e-commerce store, that's a lot of potentially lost revenue, that's a lot of service outage for your consumers and so forth, and can cause some problems. So having options where you can deploy somewhere else for a period of time. Maybe you leverage a third-party load balancing service where you can route DNS somewhere else temporarily for a period of time is important. But there's some challenges there, and the first is that APIs are going to be different. So if you start looking at AWS and interacting with S3, it's very different from interacting with Windows Azure storage, blob storage. Now, it's not tremendously, I mean, in many ways it's very similar, but when you start interacting with their APIs, their REST APIs are going to be different. And so you have to account for that. Now, one of the best ways to do that is to start building some abstraction on how you interact with storage. And your ability to do this is going to be governed a lot by your budget, the amount of time you have, and so forth. And many of us don't always have that. But if you have the time, if you have the budget, it actually starts to make sense to build abstractions on top of different cloud platforms so that your application is interacting with your APIs, but those APIs are then able to abstract some of the differences between the platforms. And this is not just storage. This is also with regards to networking, how you provision machines. If you look at Amazon, they've got AMIs. Windows Azure has VHDs. So there's going to be some differences. But finding a way to abstract across those so that you can deliver the best SLAs for your app is actually pretty important. And then the last point is just that there's going to be different tactics and different ways to use this, and you need to account for that when it comes to these different cloud platforms that you're going to leverage. One way to do this, or at least to start up front, is coming from a Windows Azure background, I will inherently end up saying Windows Azure Blob Storage when what I really mean is just some kind of binary storage location. And so the vernacular that you start to adapt and use internally, if you can start to make it also a little bit more abstract and not specific to the underlying platform you're using, this can actually help. And it's one thing that I've started to do at Aditi is, we're not just talking about blobs or containers within blobs and so forth, which are very specific to Windows Azure. We start talking about more generic things, volumes of data, things like that. The other thing that really helps too is to start thinking of what types of resources can and should live in different clouds. Well, somehow I locked the, sorry about that if I got anyone in the eye. I'm going to go a little crazy with the pointer. You don't necessarily have to build everything for different cloud platforms. I personally would say an approach would be think about some of the more important resources that you absolutely cannot live without and figure out how you might be able to have some way of recovering certain things in another platform just to provide the base set of capabilities needed in order to continue to operate, rather than having to figure out how to abstract and rebuild everything across platforms. So just a couple of points there. One thing that really helps to reinforce all of this stuff, best practices, the right things and so forth, is automation. And with Windows Azure, one of the things that the team I was on worked on for a long time, in fact, the team still ends up supporting, are these PowerShell commandlets for the platform. And I have gotten very used with Windows Azure to automate everything. So I'm a developer as a background, so I spend a lot of time in Visual Studio. But when it comes time to deploy and to get my assets up into Windows Azure, I don't just right-click and publish all the time. I will actually spend the time to write some scripts that make it easier for me to deploy the apps. And it's a practice that I think is really useful. And being able to do that means that you can very quickly automate these sorts of things. And you get used to it where now I have a number of scripts where I can run a script and have stuff deployed. I can deploy some VMs. I can have them I can deploy some VM servers. I can have them join a SharePoint farm. I can have them connect to SQL backend, all through running a script. And actually, incidentally, one of the things that really helped me here is I've built a lot of keynote demos for execs at Microsoft over the years, for TechEd, for Mix, et cetera. And one of the things you have to be able to do in those keynotes is every time an exec makes a decision and changes something, you need to be able to reset the entire environment just instantly like that so that you can start over and do something different. And having that kind of automation really, really helps, not just in demos, but in practice as well. And having this kind of automation is going to help you practice, help you find the flaws in your recovery problem, and so forth. So all of this said, all these slides, by the way, are already available. If you guys are familiar with SlideShare, I've got these posted up in SlideShare. I believe it's like slideshare.net/Wade Wegner. So you absolutely can grab these. You don't have to try to take notes of everything. But I have put together a list of things for high availability and disaster recovery that actually came out of a lot of work that we did at Aditi when we started looking into this, and I think they're just some good things to consider before we get into some of the patterns and some of the other stuff. And by the way, too, I realize the presentation is pretty top-heavy with a lot of these concepts, so hopefully this is still worthwhile, but I do want to go through this because I think it's important. The very first thing I think is to define ownership within the company, like who is ultimately responsible for these items. In many companies that I've worked in the past, it's not been clear who's responsible for designing and architecting the right disaster recovery process, or when a disaster occurs, who's actually on point, who gets that call or that page in the night, and then who's responsible for testing this as well and making sure that all these things work. So getting clear ownership up front, I think, is very important. You have two options when it comes to the expertise in being able to do that. One is, and this is assuming, of course, you already don't have it in-house, but one is to develop it in-house. And certainly is possible, but you need to take into consideration the risk-reward. Like, are you willing to wait for this type of in-house expertise to blossom, or do you need something today? Because the other opportunity would be to get some outside help. There's certainly a lot of companies out there that have this kind of expertise and can provide it. The next would be to actually not just do an assessment overall, but at the application level. Actually go through and take a look at each application and understand the dependencies. How do they work together? And to get a good map for what happens. Like if you've got a bunch of applications running up in Windows Azure, you've got a bunch in a third-party hosting provider, you've got a bunch on premises, understanding the interdependencies and how these things work together is important to understanding the, your overall risk when it comes to these types of failure. It's really important to understand the recovery time objective and the recovery point objective. And this is going to become very important when you start looking at the different patterns that you can use. Not every system needs to be recovered within 30 seconds. Sometimes it's okay for a system to take an hour, 6 hours, even a day. And consequently, you can use different types of architectures and designs for what your disaster recovery is and how you try to account for it. And so when you go through and you do this assessment for each application, it's important, I think, to understand and to list what is the recovery time objective for this app. The other thing is then the recovery point objective. There's some systems where the data is critical. You need to have that transaction log up to the second so that you can recover the database. It's really key. There's other ones where best effort, having it within 30 minutes, an hour, et cetera, is okay. And that's going to dictate the type of options and the way in which you replicate data, the way you ship data, et cetera, to another place so that you can recover to it, or recover that data. So it's really important for each application to know the recovery time objective and the recovery point objective. Design for failure with your application architecture. So I'll give it some examples with Windows Azure. A lot of people that I'll see are like, well, I've got an ASP.NET application and it uses SQL Server, so I'm just going to create a web role and I'm going to put my ASP.NET application in the web role and I'm going to put my application in SQL Azure and I'm going to be done with it. And that's a start, but it's not really designing this highly available system. There's things to consider, like with SQL Azure. There are going to be transient faults in your connectivity to SQL Azure. SQL Azure is a multi-tenant environment. It means that your database and your data is living with other tenants, and there's going to be times where you'll make a request to SQL Azure, and that request will time out, your connection will drop, those sorts of things. And so designing the application architecture for the platform means that you're taking into consideration these types of things and mitigating it. There's a transient fault application block that you can use with SQL Azure that introduces things like retries or trying to reestablish connections and so forth. In fact, I think Chris Auld is doing a talk tomorrow morning on Advanced SQL Database. By the way, I keep saying SQL Azure. That's just a bad habit. It is Windows Azure SQL Database. SQL Azure was the previous name. It was rebranded. They're the same thing. Chris will be talking about it. I don't know the exact content, but I have a feeling he's going to be talking about some of these patterns, the transient fault handling block and so forth within it. So, but understanding the systems and designing that application architecture specifically for it is important. Let's see, what else is here important? Documenting these processes is key. You need to have a reference point because people leave companies, they move on. If there's that one person that knows exactly how to go through this process, and they're the only ones that really know all the steps, then you're in big trouble. So making sure that you've got all of this documented in the process is critical. And then testing it and testing it and testing it and continually testing it is really important. Now the last point is kind of a fun one. As most people here heard about the Netflix Chaos Monkey? Basically, it's the idea that Netflix has designed their system such that they will take things offline at any point, and it forces their developers and forces their IT to design systems that are redundant and durable and so forth, because at any point in time, they may not have access to the database, or their networking may go down and so forth. And there are things that you can do internally to do the same sort of thing. Like with Windows Azure, you could write some scripts that could go off and change configuration settings so that your app is no longer able to connect to the database. Things like this. I wouldn't necessarily recommend it for everyone, but there are things that you can do, especially like in integration testing when the systems come together, or in UAT or things like this, where you could introduce some chaos into the system just to kind of see what happens. What's going to happen if the network cable gets unplugged and you can't connect to the database backend? Because at some point that could happen in production, and you should have a good idea for how the system recovers ahead of that happening in production. Now, so this is kind of the checklist. Now, some best practices. Of course, avoid single points of failure. I think that's obvious. I don't think anyone's surprised by that. The next point, always place at least one of each component in two different availability zones or fault domains. And that's important. Hopefully everyone understands the concept of an availability zone and a fault domain at this point. But when you deploy something to Windows Azure, make sure that you've got at least 2 instances of this running, and make sure that you've got the fault domain specified so that if something does fail, you still will have the ability to handle requests as it comes to the application. So important things to do. Make sure that you've got enough capacity. Now, AWS has this concept of reserved instances, which is really nice, which means in the event that you actually need additional capacity, you've got that reserved, and you know that you're going to be able to get it. Windows Azure doesn't quite have it today. Windows Azure will try to reserve enough capacity in a data center to account for needed increases. So Windows Azure won't just allocate all the instances, all the compute instances, everything within a data center. It does try to keep a certain reserve capacity so that when people do need to end up scaling up and so forth, that capacity exists. In the event of data, when you're working with data, let's say you've got SQL Server running in some sort of durable VM, you need to make sure that you're replicating that data across availability zones or fault domains. So with Windows Azure, the introduction of infrastructure as a service this summer has been key, but it doesn't solve every problem. Like if you spin up 2 VMs and don't specify different fault domains and you have them running in the same place, just because you've got 2 SQL servers that are replicating data across them doesn't mean that you've got any sort of high availability. You need to make sure that those VMs are running in different locations so that in the event that one goes down, that secondary machine is available for you. Having the appropriate monitoring and alerting in place is really key. There is, like in Windows Azure, there is monitoring built into the platform, so you'll get performance counters, you'll get metrics and so forth, but the alerting is what's key. You need to be able to know the instant something is down. You can build this, it's certainly possible. There's also a lot of third-party providers that provide monitoring solutions that you can interact with. I definitely recommend taking a look at some of them. There's everything from Redgate to Obstera there's at least a dozen. At one point, I jokingly said that there were more cloud monitoring solutions than there were cloud applications. That's not quite the case anymore. There's quite a lot of cloud applications, but there's a lot of different monitoring solutions, and it's important to use them because you need to know. In fact, I missed the obvious one, System Center. System Center is a great monitoring tool for you to use as well. The last point I think is also important, especially when you look at Windows Azure from a platform as a service perspective. And this is something unique to Windows Azure that you really should take a look at, and that's the platform as a service capability. That it's unique to Windows Azure. AWS has some concept similar to it, but not quite the same. And the thing to point out with platform as a service when you start looking at these cloud services, to make sure that these applications are built to be stateless, such that in the event of failure, Windows Azure will detect that there's a problem and it will restart your machine somewhere else. The state of the machine will be gone, and this is why we say build stateless apps. So you need to make sure that that state is externalized somewhere else. so that when that machine starts up somewhere else, it has the data it needs to in order to function. All right, so here are some of the scenarios that we're going to walk through for disaster recovery. And this is what I think is really interesting based on using the cloud in order to provide different disaster recovery, because a lot of these different solutions become more affordable and more approachable to us now that we have the ability to provision and procure this infrastructure pretty quickly. So we'll walk through this as we move forward. Now, here's an example of a pretty typical application. I've tried to design this such that this would work well and map to both AWS and Windows Azure. It breaks down in some places, and I'll try to talk about that when possible. But here's a case where you've got an application, you've got multiple fault domains or availability zones, and that application, let's say you've got 4 instances of it. You've got some of the instances running in one fault domain. You've got some running in another. Now, the biggest challenge you end up having here is that you need to have data consistency, especially with a relational database. So you can see all the arrows end up pointing to one database. Now, obviously, that's a single point of failure, because if that fault domain or if that database goes offline, then it actually takes it off for everyone. So this is where having replication and the ability to have other data available in the event of a failure is quite critical and quite important. Also, this is where taking advantage of platform capabilities becomes crucial as well. For instance, SQL Azure does have some of this fault tolerance and availability built into it. So if you were to use SQL Azure, then you'd actually have a lot of fault tolerance. SQL Azure has this concept of a quorum. So it won't actually release a SQL connection until a quorum of servers behind the service endpoint have actually got some consistency with the data. So that way, if one of the servers that are working with SQL Azure goes down, that data still exists elsewhere, and another server can end up acting as the master in that event. But if you're doing this yourself, let's say you're using infrastructure as a service, you need to have an ability and a way to replicate and move this data over somewhere else, so that in the event that that machine goes down, you can connect to it. A lot of times you see that there's external storage. That's actually for an event where you basically want to take backups of both your primary and secondary volumes, so that those backups end up existing somewhere else. Because if something happens to master, you not only want to have a slave available, but then if something were to actually happen to that slave or to that secondary machine, you need to have some sort of backup there as well. So this is one way of looking at kind of a single cloud solution or architecture using multiple availability zones or fault domains. So that's kind of the prototypical example. Now, looking at some of these different options here, what I've tried to do is, you remember there's this concept of how quickly does something need to be recovered, and how much data or what point of time do you need to recover it in. I've tried to plot some of this stuff here so that you can take a look at some of the different options and the costs. And certainly this is a generalization, but I think it's reasonably accurate. So on the one side, on the y-axis, you've got no downtime at the top with a few hours at the bottom, and on the x-axis, you've got a cheaper solution to a more expensive. And your cold disaster recovery to warm disaster recovery to hot high availability, and we'll get into those now. So here's an example of could be a multi-cloud. This kind of gets into a case where Cloud 2 could be a different cloud platform. Remember now, when we're talking about cloud, we also mean it at the data center level, which means that it could just be a different data center within Windows Azure as well. Cloud end up being those physical resources behind an API endpoint. So it could end up being all in Windows Azure. It could mean that you're also using some abstraction and running some in Windows Azure and some in another cloud platform as well. But the idea here is that in a cold recovery, all you really have that's consistent between the two is your data storage. So you have some kind of backup data that's, maybe you take a SQL database backup and you throw it up in Windows Azure Blob Storage. You've got in one cloud a load balancer. You've got your application running, preferably probably in different fault domains, and then you've got your data. And in the event of a problem or a failure, what you will end up doing is you will spin up the entire infrastructure somewhere else, and then you'll use the data that's on that data storage location to do a restore into your database, and then you'll bring everything up and running. This is certainly a most affordable approach because you're not keeping any other systems running in parallel, but it certainly takes longer to recover. It means at the very least, you have to spin up your data tier, you need to do a restore into it, and then you need to spin up your web tier, and then you need to switch over DNS to point to the new environment. That can take time. Again, fully automatable, you should be able to automate all of this, but it will take time to boot these things up and get things back up and running. And it means that it takes longer, and your data restore is probably at an older point of time as well. Now, a warm disaster recovery means that it's very similar to the past one, but in this case, the thing that usually takes the longest to end up getting back up and running is going to be your data tier. And in many cases, this is the thing that you want to be as consistent as possible as well. So in a scenario like this, you may have your full system running up in Windows Azure in the North Central data center. In the South Center data center, you may just have your data tier running, and you may configure mirroring across it. Windows Azure Infrastructure as a Service does support for your high availability options in disaster recovery, SQL mirroring. So this is a very good approach. On both cases, you're going to want to have backups taking snapshots of your data and putting it somewhere external as well. Just again, in the event that you do have problems with those, and plus many times it's not, maybe it's operator error. Someone accidentally issued a drop table command. You just need to make sure that you've got that data externalized somewhere else as well. But the benefits here are that from a cost perspective, it's still relatively low because you're really only talking about having one other system live up and running. But when it comes to spinning things up, it's actually a lot faster to spin up your application tier than it is the data tier. For instance, if you're using Windows Azure Platform as a Service, everything's encapsulated in your package in your CSPKG file. It's just a matter of handing it off to the Fabric controller and letting it spin things up. So it's a lot faster in this case to recover. You're really just talking about how long it takes to get your app tier up and to cut your load balancer over, your DNS over to somewhere else. Generally, this is probably the approach that most people would end up taking. Now, in a hot scenario, really what you're talking about is you've got, in many cases, things running in parallel. And then when there's a problem, you'll end up switching things over. It may mean that, again, you're probably trying to mirror this data. And what you're going to end up doing in this case is actually really just flipping over your DNS and the way in which you resolve the site. You can use, like Windows Azure provides the Windows Azure Traffic Manager, which provides you the ability to actually change the resolution of your cloud services and your applications. There are also third-party services that you can use as well, just to control how your application, where your application resolves. So this one, obviously, you imagine is more expensive. One way that you could look at this as well is your app tier doesn't need to be scaled out to exactly what your primary scenario is. You may decide just to have one or two instances running. Maybe if you're using something like Windows Azure, you've got some extra small instances set up and running, and you may change that in the event that there's a problem. But this allows you a lot faster recovery at a cost. The last really is when you really want to have high availability. And the difference here is we're not talking about recovering from something and having some downtime and so forth. We're looking at high availability so that even if a cloud, again, a data center or something goes down, you've got the ability to work with it elsewhere. And this is where a service like the Windows Azure Traffic Manager is really, really valuable, because you can use it to do DNS routing at that traffic manager layer across multiple clouds. And in many cases, you can actually optimize it for performance first and availability second. So imagine the case where you've got your applications running in parallel in the North Central database and the South Central database, or data center, sorry. You've got these in the North data center and the South data center. Depending on where your incoming traffic is coming from, it can resolve it to the closest data center to keep performance optimized and best. If something were to go down and Traffic Manager is no longer able to communicate with, let's say, the North Central data center, not database, data center, it will start routing traffic to the South Central data center. So having these types of services in place to route your traffic accordingly can really help from a high availability perspective. So in this case, you've got everything running in both. You're sending traffic. It could be round robin. It could be based on performance. It could be a number of different ways that you've got it configured, but you're actually sending traffic to both places. So if one goes down, it still works. Now, do note that still you've got that database, that data consistency challenge, and this is just something that we're going to deal with all the time until something amazing is invented. Actually, I guess there are some things being built, but beyond the scope of this talk and beyond my knowledge. But if you're using a relational database, it means that you're probably working, everything is pointed to one, and you're going to have a way to flip over to the secondary if there's a challenge. And there's a lot of different techniques. You could have scripts. You could have it, you could have something pinging endpoints, and if it's not available, flip things over and so forth, so that you can still have some high availability built into the platform. So, how am I doing on time? I went pretty fast. I had some coffee ahead of time, so I think I've been talking fast. So we will have some time for Q&A, or everyone can break and go to the party early. I don't know when it starts, but I think to end, I wanted to have some points. How do you make your service immortal? And this is actually there's a friend of mine, Brian Prince, that talks about service immortality, and so it's kind of alluding back to that. But I think that's the goal here. And so the first point is, be pessimistic. I mean, things will fail. Hardware is going to fail, software is going to fail, or people are going to fail. And we've got to have the process in place, the automation to recover from it, all these things accounted for ahead of time so that we can recover for it. Embrace the cloud. Don't just take your application and figure out the easiest path for moving it into the cloud. Take advantage of these building block services, these capabilities that the cloud provides, because that's going to help maximize your ability to have a highly available solution. I see a lot of people that, when SQL Azure first came out, the database size was pretty small, and it's grown over time. I think it's 150 gigabytes now. But in many cases, people would complain, oh, it's just not big enough. I have 50 gigabytes of data, and I can't store it all in there. Well, it turns out in many cases, a lot of this data is binary type stuff. It's images and video, things that were thrown in the database. And one of the first things we do is we figure out how do we modify that data structure to leverage things like Windows Azure Blob Storage. Not only does that get that out of the database, but it puts it in a more optimal environment for it. Not only does it help from a recovery perspective, it's more available. There's replicas, but you can attach it to the CDN, blah, blah, blah. So taking advantage of the platform capabilities is key. Another one that a lot of people miss as well is caching. How many of us have built ASP.NET applications that do in-memory session state management? I mean, it's great from a performance perspective. Then you hit a web farm and, oh, darn it, now I've got different data in different places. So you externalize it to SQL Server. There are caching services in Windows Azure. There's a Windows Azure caching role. And you can build a highly available in-memory cache that's running up in the cloud that has multiple instances running in it so that even if there's failure of one, your data still was replicated across that cache cluster. So you've got availability built into it at that point. You can externalize that application state into that cache. So definitely take a look at that platform and embrace that cloud mentality. The next point is have it your way. I mean, there's a lot of generalizations that I went through in this talk, and I can't account for every single different scenario, and I've likely missed a lot of things. But the point I just want to make is that there's no single truth. I mean, and no architecture is best. You have to do that assessment of all these applications and then figure out what makes sense based on how quickly you need to recover it and how much data you're willing to lose. And then the next point is don't wait to just do everything at once. Crawl first, figure out how to walk, and then eventually run. There are things that you can slowly start to do, and things that you can take advantage of within these platforms to build more available applications. All right, so I'm a little bit early, but yeah, definitely there's a lot of different resources. Feedback is great, and any questions, I mean, certainly if anyone has any questions, happy to take them. If no one has any questions, we can break early. Sorry, I didn't mean to talk so fast. So, sir. Yeah. So the question is, in this scenario, you got 1 point of failure potentially with your SQL environment. So a way to take advantage, one tactic for overcoming this is to use something like Windows Azure SQL Database. So that is built into that service. It's a managed service. I mentioned, and Chris will go, I'm sure, tomorrow in more detail, but this concept of a quorum. So that transaction is never released until there's consistency in at least, I think it's like, I forget how many servers have to, acknowledge before there's a quorum, but that data ends up living in multiple places. I will admit there is, when you start looking at that kind of an architecture, a SQL database will have a slightly more, there will be a performance impact on getting that kind of consistency. You need to account for that in your application, make sure that that's all right with what's needed. But that is one way to leverage a platform capability to have data consistency with no failure. The other things that I've seen is you start to deviate a little bit from high availability, but it's getting, in a durable virtual machine, SQL Server set up and replicating data so that it's just continuously replicating. You have to be able to tell your application to switch over to your secondary database server. So you can do that through a number of different things. One way that I've ended up doing it before is you can end up keeping the connection string either in an external, somewhere externally configured. So it could end up being in table storage, it could be somewhere else. And then you can end up changing that and finding a way to flush your applications. So you can do that in a cascading way. Again, there may be some impact to your availability, but you could end up flipping over your apps to point to a different database server in that scenario. Correct, yes. Versus SQL database, SQL Azure. Yep, absolutely. Now, another option would be there is the SQL database data sync service. So you could end up having two different databases living in different clouds and using data sync. There will be some data inconsistency between there because it takes some time for data sync to actually synchronize and replicate. But that's another option. And again, it just depends on the tolerance you have for, maybe some inconsistency between data in one place and data in another place. The devil's in the details. It's going to vary in many ways. Sir. So the question was, what kind of technology have you used to back up to storage? Within Windows Azure, there is an ability to do export imports. So you can actually, it's called SQL Server. It's SQL. Is it the DAC pack? The DAC pack, which is a DAC pack? Yeah. So DAC pack basically is an export that not only has your SQL schema but the data as well. Or is it the backpack? It is the backpack. Sorry, backpack, DAC pack. I actually don't even know what they stand for, but DAC pack, I guess, is schema only. Backpack is schema and data. So within Windows Azure, as part of SQL Database, you actually have the ability to create a backpack, and one of the defaults is to store that backpack into Windows Azure Blob Storage. So you can end up using as that externalized data Windows Azure, Blob Storage, and then that backpack gets stored there. And then, of course, you can do an import of that backpack to recover schema and data. So. That's a great point. So so this is all transactional. So you can do a database copy, right? So in SQL database, you can perform a database copy. And what that'll do is it'll actually create a transactionally consistent copy of it, and then you can use that to generate. In fact, I think I did, see, I've got that secondary volume. That was the intent there. So that's actually the volume that you would end up creating the backpack off of.
So I guess so it sounds like it's not incremental then, and so if you've got hundreds of terabytes of data.
It's actually good. So the question was, it's not incremental. I am sure, I'm not a backpack expert by any means. I would be very surprised if the SQL team didn't account for that and let you do differentials for your backpacks as well. Yeah, if anyone knows, I mean, the gentleman that obviously knows a little bit more than I do about it doesn't know. So, but it'd be worth looking into. Maybe there's a SQL expert here. I don't know the answer to that. Any other thoughts, questions? Sir?
You mentioned with SQL, as if someone goes through and exits the drops table your stuff.
Yep.
Have you seen any decent solutions for similar sort of DR for Azure storage?
For Windows Azure storage, like Blob's?
So if someone goes through and deletes a block.
Yeah. So the question is, so obviously someone can, truncate a table, to drop a table, et cetera. And with SQL, you can, even though there's no like point-in-time recovery or specific backup set up in the database, there are ways to get around it. You can do copies, you can create exports, and so forth. With Windows Azure Storage, the platform does not provide any tools for you. So it will replicate data to a different data center, but that's within 10 minutes, and you don't have access to it. So it means the whole data center has to go down before it actually uses it. So my answer is the platform doesn't have this. I have seen a lot of solutions. I've written some that are not quite so good. The best I've seen is Redgate actually producing tools. So if you take a look at some of the stuff Redgate's produced, I don't like specifically endorsing one company over it. There's actually a lot of third-party out there that build some tools, but I think Redgate's got some pretty good tools for copying and synchronizing Windows Azure Storage. So. Great. All right, well, feel free to come up with any questions. I hope it was worthwhile. And please, again, it's not up here, but everyone knows aka.ms/mobile for feedback. So I would love to hear from you. So thank you very much.